Alright, now that Unit 3 is over, I know that was a really hard unit. Unit 4 should be a lot easier, and we're going to start off pretty simple today by talking about inequalities being true or false. So this is lesson 4.1. Inequality is just another true or false question. Your aim today is I can determine if an inequality is true or false. So let's do a little review here. This symbol is a less than sign. This is a less than or equal to. This is a greater than sign, and this is a greater than or equal to. Okay, now these are things you need to memorize. For right now, put them on your notes, and we're going to keep referring to them as we get along in the lesson. Alright, let's start. So far, we've concentrated on solving equations. Remember, all solving an equation consisted of was finding values of the variable that made the two expressions equal. In other words, made the equation true. We can also judge the truth value of a statement that is in the form of an inequality. So a math statement could be an equation, an expression, something that relates two values together. Okay? So exercise 1, for each inequality, state whether it's true or false. Number 1, 7 greater than 3. Is that true? Absolutely. 7 is definitely bigger than 3. Letter B, is 0 less than 10? Yes, it's true. So we're going to write true. Letter C, is 9 greater than 12? Nope, 9 is not greater than 12. Letter D, 4 less than or equal to 4? Yes, that is true. 4 is not less than 4, but it is also equal to, because it's got that little line under there, right? This is a less than or equal to. Okay? Try the next 4 on your own if you like. Pause the video and try on your own. I'm going to continue. Letter E, 2 greater than or equal to 7? That is false. 2 is not greater than 7. Letter F, 3.5 less than or equal to 4.2. That's true. 3.5 is a smaller number than 4.2. Letter G, 265 is greater than 312. That is false. That's a smaller number. And finally, H, 1,978 less than or equal to 2,042. That is true. So it's just a little review over the inequality signs and symbols. Okay? It's quite easy for most students to judge an inequality when the numbers are positive. Okay, that's like all of these numbers we just talked about were positive, right? It becomes much more difficult when negative numbers are involved. Consider the statement, -8 is less than 4. Do you think this is true or false? Why? Well, when you first see this, you think, oh, 8 less than 4? Wait a second, 8's a bigger number than 4, so this must be false. But we are thinking about -8 as being less than 4. One way I like to think about negative numbers is I like to think of this as a minus sign as like owing $8. And the 4 is like having $4. Okay? If I owe $8, that's definitely less than me having $4, right? If I have -8 in the bank account, that's lower than me having $4 in the bank account, right? So this is a true statement that -8 is less than 4. Okay? Now, one way we can think about this is thinking about a number line, okay? There are lots of ways to define how one number is greater than another, and we're going to use a graphing definition. So let's take a look at our definition of inequality. If we compare any two numbers, say A and B, so A and B are numbers, okay, we will say that A is greater than B is true if A lies to the right. So another way to say this, in not such complicated terms, is that the bigger number lies on the right of the number line. And I'm going to show you an example of this in the next exercise. Okay? So exercise 3, give the truth value for each of the following statements. Draw a number line to support your work. So let's look at letter A. Okay, A says 3 greater than negative 4. Okay, let's draw a number line. So here's my number line. And I've got 0 here, 1, 2, 3, 4. And negative 1, negative 2, negative 3, negative 4. So here's negative 4, and here's positive 3. Which one lies farther to the right? This one. So 3 is a bigger number. So yes, this is true. 3 is greater. So one way we can test our inequalities is by graphing them. Okay? Letter B. Negative 5 is greater than negative 3. Let's draw our number line. Okay. And I'm going to put negative 1 here, negative 2. So here's negative 5, and here is negative 3. Which one's the bigger number? Negative 3 is bigger, so that means that this has to be false. 5 is not greater than negative 3. And for some reason my pen got a little bent, so when I write on my board, it kind of blurs together. So I'm going to try and be a little careful about that as we go on here. Finally, letter C, draw my number line. Notice how when I draw my number line, I'm not always starting with 0 right in the middle. Like here, I'm going to start with 0 on the far right side and go down to negative 1, negative 2, negative 3, negative 4, negative 5. I need a little bit more room, so I'm going to erase that, and there's my negative 6. Okay, your number line just has to make sure that it's going up by the same amount. It doesn't necessarily matter where my number line starts or ends. So here's negative 6, and here is 0. Is 0 greater than negative 6? Yes, 0 is bigger. So that means that this is true. 0 is greater than negative 6. Okay, so this is graphing inequalities. Alright? So, since we can test inequality of numbers now, we can also test the inequality of expressions for values of variables. This is identical to checking the truth value of an equation. This is like, in the way we put it before, it's like plug and... My pen is just being kind of a pain. Let's try this again. This was like plug and chug. We plug something in and we get out a value. So let's take a look at A. Given an inequality, 3 times x minus 2 is greater than or equal to 2x plus 1. Determine if it's true or false for the following values of x. So we're going to just plug this in. So I'm going to have 3 times, instead of x here, I'm going to put 10 minus 2 is greater than or equal to 2. Instead of x, I'm going to put times 10 plus 1. And now I'm going to simplify and see if this works out. So this becomes 3 times 8 is greater than or equal to 20 plus 1. 3 times 8 is 24, and 20 plus 1 is 21. Yes, this is true. 24 is greater than 21. This is true. Okay? Why don't you try the next 3 on your own by plugging in these values in for the equation and see if you can determine if it's true or false for that given value, right? We're trying to see if this number makes inequality true or makes inequality false. Okay, so pause the video and try on your own. Alright, now that you've tried on your own, let's take a look at your solutions. I'm going to have 3 plug in the 5 minus 2, greater than or equal to 2 times 5 plus 1. That should be a plus. This becomes 3 times 3 is greater than or equal to 10 plus 1. 3 times 3 is 9. Oh, my pen is just doing kind of crazy right now. 9 is greater than or equal to 11. Is that true? No. 9 is not greater than 11. so that's false. Okay? Letter C, plugging in the number 1. So I've got 3 times 1 minus 2 is greater than or equal to 2 times 1 plus 1. 1 minus 2 is negative 1. 2 times 1 is 2. Bring down the 1. 3 times negative 1 is negative 3. And 2 plus 1 is 3. Now I have to think, is negative 3 greater than or equal to 3? Again, think about the money. Is owing $3 greater than having $3? No, this is false. And again, if you need to graph it to help you. Sometimes this helps. 1, 2, 3, 1, 2, 3. If you need to use the number line at the front of the room when you come into class, here's negative 3, here's positive 3. This one is the bigger number. So this is false. Okay? Letter D, we're plugging in 7 now. So 3 times 7 minus 2 is greater than or equal to 2 times 7 plus 1. So this becomes 3 times 5, because 7 minus 2 is 5. Greater than or equal to 2 times 7 is 14 plus 1. 3 times 5 is 15, and 14 plus 1 is 15. Is 15 greater than or equal to 15? Yes, it's equal, so this is true. Alright? Finally, now we have to think about equations that are a little more complicated, right? Notice that unlike equations, inequalities tend to have many values that make them true. So if I go back, notice that the number 10 worked, the number 7 worked. We'd have lots of other numbers that could possibly work. Whereas an equation only has one solution, infinite solutions, or none, right? An inequality can have a certain amount of solutions, which makes them a little unique, okay? So exercise 5, we're doing the same thing again. For each of the following inequalities, determine if it's true or false the given value of the variable. So the only difference with exercise 5 is that these equations are a little bit more complicated. They're just a little bit longer and require a little bit more thinking, okay? So let's take a look at A. And again, you can pause and try these on your own whenever you like. I'm going to plug in x equal 1, so it'll be 2 times 1 plus 4 is greater than 4 times 1 minus 1. PEMDAS says I do 2 times 1 first. 4 times 1 is 4 minus 1. 2 plus 4 is 8. Is 8 greater than 4 minus 1, 3? No. This is false. Not true. 8. Oh, wait, I'm wrong. 8 is greater than 3. Sorry. True. See how easy it is to make mistakes? You guys catch me on them all the time. Letter B, I'm plugging in x equals negative 3 now. So I have negative 3 times, instead of x, I'm going to put in negative 3. Be very neat with your work. Okay. Again, here's another x. I'm going to replace it with the negative 3 plus 7 over 2. And again, you can always use your calculators for simplifying. You cannot put the inequality signs into the calculator, but you could put the left side of the calculator and the right side in, and then simplify that way. Let's do it by PEMDAS, though, to get that extra practice. Negative 3 plus 5 is 2. And then on the right side, negative 3 plus 7 is a positive 4. I'm going to bring down the division by 2. On the left side, I have negative 3 times 2 is a negative 6. Greater than or equal to 4 divided by 2 is 2. Now, is negative 6 greater than 2? Nope, it's not. I don't want to owe money. I want to have money. So that is false. Okay. Letter C introduces some exponents, and something we have to remember when plugging in with exponents is that we need to use parentheses. So when I plug in x is negative 2, I'm going to put the negative 2 in parentheses when I square it. There's several reasons for this. One major one being signs are going to change if you don't put the parentheses in, especially if you're using your calculator, so we have to be really careful. Minus 10. Again, I'm going to put the negative 2 in parentheses plus 1. That's the left side. On the right side, I have 20 plus 5 times negative 2. So whenever I have negative numbers I plug in, I always use parentheses. You don't want to make sign errors, so be very careful. Negative 2 squared is 4. The next thing is this negative 10 times negative 2 is a positive 20. I'm going to bring down the 1, and I'm going to simplify the right. Bring down the 20, and then 5 times negative 2 is a plus negative 10. On the left side, I just have to add these together. 4 plus 20 is 24, and 24 plus 1 is 25, and 20 plus negative 10 is a 10. Is 25 less than 10? Nope. So this is false. Negative 2 does not work for this inequality. And finally, the last one, we're plugging in a 5 into this inequality. So I have 2 times 5 minus 5 plus 1 divided by 3 is less than or equal to 5 minus 2 divided by 9. So wherever I saw x, I just replaced it with a 5. I didn't use parentheses this time because I'm working with a positive number, so I'm a little less afraid of making a sign error. Now I'm going to simplify using PEMDAS. This top part, 5 minus 5 is 0, so I get 2 times 0 plus 1 over 3 is less than or equal to 5 minus 2, which is 3 over 9. 2 times 0 is 0, so that kind of just cancels out and is gone, and I'm left with 1 divided by 3. And then 3 divided by 9, if you put that in your calculator, simplifies to 1 over 3. Is 1 over 3 less than or equal to 1 over 3? Yes, it's equal, so 5 works with that inequality. Okay, so that's the basic lesson on inequalities. It's the first lesson of the unit, so we're just thinking about how less than and greater than works with plugging in numbers and making sure we understand that if a number is laying to the right of a number line, then it's bigger than a number laying to the left. Okay, so use those number lines to help you. Good luck on your fluency, and if you have questions, you know where to go.